Welcome back to the Massive Loop SDK tutorial series. My name is Brandon, and I'll be guiding you through this 5th episode. In the previous tutorial, we went over Lua scripting and showed you how to build a sci-fi rifle, as well as creating many other kinds of interactions using scripting. In this episode, we'll dive into a couple of new scripts and learn how to make them work in a multiplayer context. We will look into 3 main ways that we can synchronize logic and data in Massive Loop. Lua events, which are for synchronizing events, syncvars, which are for synchronizing data, and the ML synchronizer for synchronizing objects and components. Now, because Massive Loop at its core is a multiplayer environment, we'll first learn how it's structured. When you join a world in Massive Loop, a new room is created. A room is a multiplayer group that will house multiple players. Rooms will have a max player count that is set by the world creator. Worlds can have multiple rooms, or instances, for the same world, but the important thing to note here is that players in different rooms cannot interact with players in other rooms. The same goes for game logic within that room as well. So, as a creator, you can think of each room as its own independent world, almost like if each room is a separate multiplayer game match on the same map. Now inside each room, Massive Loop follows a shared network structure. That means that control of the game will be shared across all players or clients. In these diagrams, players are referred to as clients. The server in this case is only here to provide communication between clients. It doesn't run any of the game logic and is there only to send things to other clients. So instead, the game logic runs on every single client in the room. With all the scripts and logic we have written so far, all of it runs for every single player in this world. Now we can also have logic run on only one of these clients. This is a concept known as the master client. The master client is like any other client, except they can be used to run specific logic only on their client rather than all other clients. This will allow us to do some important things later, so be sure to remember this. Now the problem here is that all logic, whether it's on the master client or not, will run completely independently from each other. For example, say player 1 triggers an event like opening a door, but player 2 and 3 will not receive that event, and therefore the door will not open for them. So we need a way to synchronize that event across all players in the room, so that every player will know when an event has triggered. This is where we get into one of 3 ways we can synchronize clients together in Massive Loop. Enter Lua event synchronization. Lua events are used to call methods that help synchronize events across every client that is in the room. Lua events are the fastest and most efficient way to synchronize between multiple clients. That makes them great for firing projectiles, which we've done in the previous tutorial, but here we'll dive into specifics into how we can use it to our synchronizing advantage. With Lua events, there are several different kinds of calls that we can do. First we have invoke, which globally invokes a function for the current player. Next, we have invoke for all, which globally invokes a function for all players in that room. Then, we have invoke for master, which globally invokes a function both for the current player and the master client. We'll talk more about the master client again later. After that, we have invoke for master only, which globally invokes a function only for the master client. After that, we have invoke for others, which globally invokes a function for everyone but the current player. There is another set of these calls, but instead of calling globally, they will invoke a method locally on a specific script. Now with all of this covered, let's go ahead and dive into a real-world example. In this example, we have a simple door that is activated when a player steps inside a trigger volume. This trigger has a script on it that has a single serialized field that will reference the main door object. In this script, we also have some physics callback triggers for the onTriggerEnter and onTriggerExit functions. Inside these callbacks, we check if the object that entered or exited the volume is a player. If they are a player, we then reference our door object variable, get the main door script that is on it, and then call the corresponding method for opening or closing the door. Now this logic works for a single player, but the problem is that the logic is not synchronized to work for other players that would also be in the room. To solve that, we need to modify those methods so that they utilize Lua events. In our SDK documentation for Lua events, We have several different kinds of invoke methods that can be used. The one that we will use here is called invoke local for all, which will invoke a function for all players in the room, and it will call the event only on the given script object. Now, we could use invoke for all, but that invokes a function globally, and if any scripts share the same event name, they will also be triggered, which would cause all of the other doors in the map to open. For this moment, we'll stick with invoke local for all, so that it invokes the method only on this specific door. Now, we'll change this line to where simply we store the reference to the script that is on the door object into a variable named door script. In the next line, we will call Lua event invoke local for all, feed it the script reference that we stored in door script, and call the name of the method, which is a string. Let's repeat this process for the onTriggerExit method as well. Now we're not done just yet. Since now we are invoking our methods using Lua events, we need to go to our door script and register those events as Lua events. Opening our main door script, which handles logic for sliding the door to an opened and closed position, we can see our two original methods that we were calling before we switched them to Lua events, open door and close door. Now, to register them as Lua events, we need to head into the start method of this script and add the following lines to register them as local Lua events. Here, you will call Lua events add local, because we're calling them as local events back in our door trigger script. And then finally, add the actual name to the method itself. We also need to change these functions from public functions into local functions. On to testing this in a multiplayer setting. Our doors will open when players enter the trigger volume. Pretty cool, right? Lua events are the cheapest and simplest way to synchronize communication between clients. However, these are only for events, and what if instead of synchronizing events, we wanted to synchronize data? This is where we enter the second way in which we can synchronize information between clients in Massive Loop. Synchronized variables. These are variables that you can define in your script that have values that will be synchronized across all clients in the room. To illustrate this, we will use a game timer as an example. When we create a game timer script for our game, the logic as we talked about before will run for every client in the room locally. If all players join the room at the same exact time, the game timer would start counting from 0 for all clients that are in that room. This is okay, in theory, but remember that by default all game logic runs for every client independently, which is going to create some problems. For one, not all players will be joining the room at the same exact time, and because of that, their timer will be completely off compared to the rest of the players. This is known as the late joiner problem. Say that players 1 and 2 were in the room for, say, 2 minutes, and now a third player joins the room. Their game timer will start counting from 0, but the rest of the players' game time is actually 2 minutes ahead, because they were in the room earlier. The more ideal thing to do with this game timer is to instead have it run on a single client. But how can we do that? To fix those problems, we'll use a combination of syncvars and the master client concept we described earlier. Going back to our diagram example that shows the network structure of a room, we learned that there is a special client known as the master client. They are like other clients in that they can run game logic, but they can also be used to run specific logic only on the master client. So the logic runs only on one single player rather than all of them. The master client is usually the first player that joins or creates the room, but it can also migrate to other players. For example, say player 1 joins the room, followed by player 2 and 3. Player 1 is the master client. However, they decide to exit the room, so player 2 now becomes the master client. The master client only changes when the current master client player leaves. Why is this important? Well, it allows us to run the logic on a single client, rather than needing to run it on all other players. So we can run the timer script specifically on the master client, and with a combination of synchronized variables, that timer will be synchronized across all clients. So let's get started. Let's create a game timer script that simply counts the time down once a player joins the room. Create a new Lua script and call it game timer. In this script, declare a syncvar variable called syncTimeValue. Then declare another variable called local time value. Declare another variable, that being timeTextObject, which will be a serialized field that will store the text mesh, which we will use later to display the time in the world. Declare a variable called nextTimeTick, which will store the interval for when the next second happens. Lastly, declare a local variable called localPlayer. This will store the reference to the current player that is running this script. In the update function, create an if statement. If the game time is greater than the next time tick interval, then let's increment local time value by 1 to add a second. The next thing inside this if statement, we will now set our next time tick to the current time, plus a second from now. Finally, let's add a quick line of logic to set the text on our timeTextObject to reflect the new time value. Now this if block will be checked every frame, and when a second has passed according to next time tick, we will increment our game timer by 1. The next thing to do is to ensure that this code only runs on the master client. To do this, we can use the MassiveLoop Room API to get the local player. The room_get_local_player method returns an MLPlayer object, and this object has a isMasterClient boolean that returns true if the local player is indeed the master client. Now, go into your start method and we'll assign our local player to room_get_local_player. We only need to do this once. Then go back to the update function. We will add another conditional in our if statement, checking if the local player is the master client. After incrementing local time value, we'll then use it to set the value of syncTimeValue by calling syncTimeValueSet and passing in our local time value. The last step for this script is to account for non-master client users. We will do this using a syncvar callback. First, let's create a local function and call it timeValueChange. In this function, the changed value is passed through. Simply assign local time value to new value, and we'll also update the text as well. Go to the start function and we'll add the timeValueChange function to the syncvar callback on variable change. Syncvars have callbacks when the variable is set or changed, and these callbacks get called across all clients. So when syncTimeValue gets set on the master client, the value changes and triggers the onVariableChange callback, which gets called on all clients with the new value. The last thing here is to account for late joiners and to make sure that they receive the correct value. In the start method of the script, we will write an if block, checking if we're not running on the master client. Inside of this block, set the value of the local time value to the synchronized value of the game timer. That way, when a late joiner comes in, they will get the synchronized time value immediately instead of a second later, where the game timer changes from 0 to whatever the current time is. Let's not forget to update the text after receiving that new value. And there we go! A game timer that is synchronized for all players in the room, and for late joiners as well. Using a combination of Lua events, sync variables, and the master client, we can synchronize events and data for all clients in the room through scripting.
It is important to note that syncvars can create a network cost only when the value is changed, so performance is not really impacted by the amount of syncvar variables, but it's impacted by how frequently you update them.
There is one last way we can synchronize communication between clients that won't require any scripting. ML Synchronizer. We've covered this synchronizer in an earlier tutorial very briefly, but we'll touch on it again.
The ML Synchronizer is the easiest and most flexible way to synchronize objects and components in MassiveLoop. It's a modular component that has different modules that can be utilized to synchronize many different things. The ML Synchronizer can have a lot of modules. We'll only highlight a couple here. The Transform Sync module allows the object position and rotation to be synchronized across all clients in the room. The Animation Sync module allows the Unity Animator component to have synchronized animations. In addition to this, the ML Synchronizer can also be used to synchronize other components, like stations or the ML Grab component. In the previous tutorial, we showed you how to make a sci-fi rifle, which had an ML Grab component. By adding an ML Synchronizer to the Grab component, not only can we synchronize its position using the Transform module, but the ML Synchronizer will also synchronize all of the callbacks on the ML Grab component. Callbacks like grabbing and trigger events. For example, in our gun script, our firing function within that weapon script is encapsulated into a single function. This function is then added to the onPrimaryTriggerDown function. That means that when the primary trigger is pressed, our fire function will be fired. When the ML Synchronizer is in use, these calls will be synchronized across all clients. The ML Synchronizer makes it very easy to synchronize objects and components within Massive Loop. However, the ML Synchronizer is the most expensive way to synchronize across clients. Just be sure not to have too many in your scene, as we don't recommend using them for projectiles or other items that would be used in large volumes. And there we have it! With this tutorial, we've covered a couple of the basic multiplayer examples to synchronizing events and data across clients. In the next tutorial, we'll dive into more advanced multiplayer examples like Player API and Cloud Variables, which will allow us to have long-term data storage for your worlds. As always, if you have any questions or need any help, please feel free to hop onto our community Discord server. Until then, happy developing!